Okay, so this was question 1, the first question from our sequences and series assignment.
Yes.
So just have a read of the question. We've got an arithmetic series with a first term, P and common difference P, and a geometric series that also has the same first term and a common ratio R. Okay.
Mm-hmm.
So I'd maybe think about kind of just writing that down. Arithmetic series, P plus, the common difference is P, so this will be 2P, and the next term will be 3P, and so on. So that's the arithmetic series. And a geometric series will be, start with the P, and then it will be P times R, and then P times R squared, and so on. Okay.
Yes.
The sum of the first 3 terms of the arithmetic series is equal to the sum of the first three terms of the geometric series.
Mm-hmm.
Okay, so what that's telling me is that if I add up the first 3 terms of the top series, that's going to be 6P. That must be equal to the sum of the geometric series. So we've got is equal to P plus PR plus PR squared.
We can factorize the P out of the geometric series and then divide it, so then P get canceled out and we only left R.
If you look at the show that answer, that should look familiar to you, right? That kind of form of an answer should look very familiar. And it should be reminding you of the quadratic formula, right? When you solve something with a quadratic formula, you often end up with an answer that looks like that. So that should be kind of leading you through this question to say, well, I'm probably going to end up having a quadratic formula for R, and then I'll have to solve that quadratic to find R. And we've got, R squared in here and an R term, so that kind of does look like it's going to happen. We need to eliminate P, right? Our answer doesn't contain anything, any P term, so we need to eliminate P. So yeah, you're right, so we have to factor out P from the right-hand side.
This is the first 5-mark question I got right by myself. Oh, I'm so proud.
Okay, now we can eliminate P and we can say 6 must be equal to 1 plus R squared. Subtract 1 from both sides. We've got that 5 is equal to R plus R squared. And now it kind of looks a lot like a quadratic equation. And we can just say, well, then R squared plus R minus 5 equals 0. And at this stage, it might be tempting just to kind of plug the numbers into your calculator, but you need to show that R is equal to that. So use the formula to show it, right? Or complete the square. I'm going to use the formula. So write down the formula, minus B plus minus the square root of B squared minus 4AC over 2A. Okay, and substitute the values into it, because if you make a mistake doing this, at least you'll get the method mark for correctly using the right method, using the formula, and substituting into it will get you a method mark. And then the final answer will be the accuracy mark. So if you did make some kind of mistake, at least you're still getting the marks here. So B is 1, A is 1, and C is minus 5. So we've got minus 1 plus or minus square root of 1 minus 4 times 1 times 5 is minus 20.
22.
Over 2, which is minus 1 plus or minus the square root of 21 all over 2. And that was the answer, to show that answer. So I think that's quite an easy 5 marks, to be honest. I didn't think that was too hard.
But still, that's 5 marks. That's a lot of marks. Yay.
Do you guys have any questions on that?
No.
I thought that one wasn't too bad. All right, this is where it starts to get really difficult, I think. These kinds of questions, you've got to be really, really careful with. Even when you're extremely careful, you're probably still going to make a mistake. So go through them real slow, check after everything, just check each line, make sure you've not done any silly mistakes, because it's so easy to make a mistake and then lose a ton of marks on these questions. Okay, so this was, whoops, question 2. Given that 1 over the square root of 4 minus x can be written in that form, find the value of p and q. So we need to rewrite this in the form shown. I don't think this is too difficult either. You should be getting used to this for integration as well, and differentiation, rewriting stuff in this kind of form. So this is 4 minus x to the minus a half, right? That's just rules of indices, square roots of fractions, and if it's 1 over, then it's minus. So I assume you're all kind of happy with that. But then if we have a look at the form it wants a 1 inside that bracket. The reason you'd want to do this is so that you could then use the binomial expansion theorem to expand this out. And you need a 1 inside that bracket to be able to do that. So that should kind of indicate to you what's going to be coming next in this question. So we want a 1 there. So if I just factor out the 4, probably going to need a bigger bracket around this. So I factor out the 4, then I can say, well, that's going to be a 1. But I need to divide the x by 4, so that if I was to distribute the 4 over the bracket, that would just be 4 minus x. Okay, and then all of that is to the minus a half. And now the last step is to essentially evaluate the 4, because this is using the rule that the square root, well, I guess it's like the square root of a times the square root of b is the square root of a times b. So all of this in the bracket is to the power of minus a half. So this is the same thing as 4 to the minus a half times the bracket to the power of minus a half.
Oh no, mistakes making.
Yeah.
Oh,
okay. So 4 to the power of minus a half is 1 over 4, the square root of 4, which is a half. 1 minus x. So be extremely careful with these steps. You should know all of the mathematics behind doing this. It's just your rules of indices and your rules of surds. So you're just factoring out so that you've got a 1 inside that bracket. They look to ask this kind of question. Yeah, go on.
So if I got this wrong, then every single thing is wrong.
Pretty much. But you might get some follow-through marks. So yeah, we'll see. But yeah, be extremely careful with these questions. It's so easy to make a mistake. Because it's minus a half, like I probably skipped a step too much here. I probably shouldn't have even done that. I should probably have written this as 1 over 4 to the half times 1 minus x over 4. And then said that that's 1 over 2. Okay, and then the question was asking us to find the value of p and q. Well, p is the number in front of the bracket, so therefore p must be a half. And q was the number, the coefficient of x, so that's going to be minus a quarter. Okay. Any questions so far?
No.
All right, let's have a look at B. So now we're asked, and I told you this this was kind of where the question was going to be going. Find the first 4 terms in the expansion of that in ascending powers of x, simplifying each term. So find the first 4 terms. So we need to make sure we're finding the first 4 terms in the expansion. So this is binomial expansion. And simplifying each term. Right, okay. So we need the binomial formula, which is, I think it's given to you, but it's 1 plus n x plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial. And this is given to you, so you should, or I mean, really, you should have this memorized as well, plus the higher order terms. So what's my n?
Your n would be minus 1 over 2.
Yeah. So this is expanding something of the form 1 plus x to the n, right? So here, n is minus 1 over 2. What's x?
X, y? What's x?
1 over 4x.
Minus
X.
1, yeah, minus 1 over 4x, right? And that's confusing. That's confusing because you just think, well, x is x, but it's not. This is a formula, right? This is a formula.
Yeah, actually it's that. Yeah, I wrote that down. Okay.
The formula is telling you for any x, and in our case we have a coefficient on the x, so we need to be very, very careful about what we substitute into the binomial expansion. You need to get that right, and that's one of the places where people make mistakes. They don't plug in the correct value for x. I'm just making sure. Is everyone agreeing with these values? Because I wouldn't be surprised if I make a mistake. Okay. All right, so now we just have to substitute in 1 plus n is minus a half. So don't do any simplifying at this point. Just literally plug things in, substitute them in. All you should be. Sorry?
Why is n minus half again?
Because it's asking us to find the first alternating expansion of this.
Yeah.
Which we just showed was equal to this. Right. So this is what we're expanding.
Okay.
Because in order to use the binomial formula, we need a 1 in this bracket to start with. So that's the purpose of rewriting it in part A, so that you can then in part B we can use this that we've kind of rewritten. So if you couldn't do part A, you kind of stuck for part B, and yeah, I mean they just assume you'll know how to do this kind of manipulation because it's just indices and surds. Part B, we've then just got to plug in the correct n and the correct x into the binomial formula, and don't do any evaluating or simplifying at this stage. Just substitute stuff in because it's hard enough, and we need the first 4 terms. So I've got 4 terms here in my formula. That's fine. So we've got n is minus a half, n minus 1 is minus 3 over 2, and then minus x over 4 squared. Okay, and then last term, minus a half for n, minus 3 over 2, minus 5 over 2, minus x over 4 cubed. Okay, so the only thing you should be concerned about is just fitting it all on one line. Don't simplify anything at this stage. Just plug them in and just make sure you get them right and check that you've done it correctly. Check you've plugged in the right x. Check you've got the square and cubed and power 1. Just check the form of it. Does it look right? Yeah, that seems okay to me. So now is when we start to simplify. So the other thing is that I actually have forgotten here is that we had a half out in front. So really,
yeah, but then you can add that later, right?
I should have a half overall.
So David, you forgot to divide by the factorials.
Yep, I did. I knew I was going to make a mistake.
Oh.
There you go. That's how easy it is to make a mistake. You look at it and think it's right, it's not. Okay, now I can start to simplify it. Cheers, Leo. So I've still got my half out in front. I'm not even going to think about that. 1 is fine. And then the way I go through this is I think, first of all, is it positive or negative?
Positive.
So, yeah, I've got 2 negatives times together. That's going to be positive. So now I can ignore the negatives. I work on the numerator and then I do the denominator. So I've got 1x is x over 8.
8.
And then next term, is it positive or negative?
Negative. Negative?
Why would it
Positive,
be
because it's minus multiplied by minus multiplied by positive.
Yeah. Minus x all squared is positive. Remember when you square something is positive. So you still got a minus times minus. So you've got plus.
Isn't that positive? Yeah.
On the numerator, I'm going to have 3x squared. And then on the denominator, I guess this is quite a lot of work because this is where you say, well, I've got 2 times 2 times 2, that's 8. And then I've got 4 squared. So I guess maybe it's worth doing an extra step here and keeping the x over 4 squared and saving that for later. And then we've got 3 over 8. And just do it in steps because it is so easy to make mistakes. And it will get simpler each line you do it, and it'll be easy to write out. The first line is probably the hardest, or the first implication is probably the hardest. It's gets easier each time. So then we want to look at our final term, and they've all been plus so far. Let's have a look at this one. So we've got minus times a minus times a minus times a minus. Right? Minus anything cubed is still negative. So that one plus the other 3 will make it positive. If you have an even number of negatives, it's going to be positive. Right? So that's the way I look at it. So we've got 3 negatives coming from the cube, 4, 5, 6 negatives in total. That's an even number, so it's positive. So add. And then I look at my numerator, 3 5s 15. The denominator is going to be 2 times 2 times 2 times 3 times 2. So that's 8 times 6 is 48. And then I've got x over 4 all cubed. Okay.
Oh, this is just way too hard.
It's a lot, yeah. What it's testing here is how rigorous are you? Like how good are you at kind of doing things in a methodical step-by-step way without making a single mistake, which is actually very important.
48 again.
Sorry?
How did you get the 48?
48. We've got on the denominator, we've got 2 times 2 times 2 is 8. And then we've got 3 factorial as well, which is 6. So it's 6 eighths.
Okay.
Okay.
Yep.
All right. So now I guess the next step will be to get rid of these brackets, and then finally I'll distribute the half. So I'm going to keep the half outside. Again, 1 plus x over 8 is fine. Right, now I've got 3x squared over 8 times 4. So what I really want to work out, and I recommend using calculators at this stage, would be like, what's 8 times 4 squared? Or 3 divided by 8 times 4 squared is really what we want. Which is 3 over 128 x squared plus, got one more, right? 15 over 48 times 4 cubed. So just use your calculator. 15 over 48 times 4 cubed. And make sure you're getting these in exact form, you're not using decimals. So this will be 5 divided by 1024 x cubed. Now I can distribute the half, and that should be the very last thing. So we've got a half, x over 8, add 3 over, it's going to be 256, x squared, add 5 over 2048, x cubed.
Wait, why is it still x over 8?
Where?
Why is the second term still x over 8?
Oh, sorry. Yeah, thanks. I did one more mistake. That should be 16. Thanks. Yeah. Is that okay? That's all right now, isn't it?
Yes.
Yeah.
How many
Okay.
marks is that?
Wait, that's the answer?
That's actually 6 marks. From the start of the question, at least that's 6 marks.
Only 6 mark? Oh,
Yeah. Yeah.
really?
And actually, we haven't finished B. So the last part of B is to state the range of values of x for which the expression is valid. So this is actually really easy, but you just have to remember. You just have to remember it. So with these expansions, they're only valid when, and I hope you remember this because it's an infinite series. They're only valid when the modulus of x is less than 1. Coming from the x from the binomial formula, right? So for this specific one, it won't be x, it will be minus x over 4 is less than 1. The reason for that is that when x, like if x was greater than 1, like imagine if x was 2, then when you're like cubing 2 and then like raising 2 to the power of like 1 billion, it's going to explode. It's going to get like a ridiculously huge number. It doesn't matter what the coefficient is in front of it. It's going to just blow up and it diverges. And it's the same thing if it's less than minus 1. So x has to be a fraction. For the sequence, for an infinite series to converge, x has to be a fraction. So just remember that it's mod x is less than 1, which is basically saying that like x is between minus 1 and 1.
That's the answer, right?
So our x is minus x over 4. So we just need to make x the subject. We can ignore the negative sign because it's a modulus function. So this is really saying the modulus of x over 4 is less than 1. So the modulus of x is less than 4, which means that x is between minus 4 and 4. And either of these would get you the answer, would get you the mark.
OMG.
Okay. So this is something to remember. Mod x is less than 1. X has to be a fraction, but just remember to substitute in your x, your specific x for your question. It'll always be different.
So where's the negative sign go? Like
why did I just get rid of the negative sign here from here to here?
yeah.
Because what the modulus function is essentially just ignoring negatives, just make everything positive.
Okay.
That's what it does. So it's kind of like for numbers, at least for ordinary numbers, what the modulus function does would be to square it and then square root it, and only take the positive square root. That's what it does. So it just makes it positive. For complex numbers, it does a different kind of thing called conjugation. For like tensors, you've got like Hermitian conjugates and all sorts of things. There's other things for that, but yeah, just remember that modulus, ignore negatives, make everything positive. So these two statements are the same, right? X is between minus 1 and 1. and mod x is less than 1. Those two have to be the same. Okay. All right, part C. So now we've got, given the first three terms of the expansion of this are a plus bx plus cx squared, find a, b, and c. So hopefully you recognize that the bottom part, at least, of this is what we've just found. We've literally just found that expansion is that. And it's that being multiplied by 2, 1 plus x. So, so what we've got is, this is part C, 2, 1 plus x multiplied by this expansion, a half, add x over 16, add 3 over 256 x squared. And I'm just going to check, where did they want me to go up to? First three terms. So it only goes up to x squared. So I don't actually need to bother writing down the x cubed term, because it's not going to influence my answer. So I don't need it. I do need the x squared term because there is a number in the first part here. So when that gets multiplied by an x squared term, it just gives an x squared. Okay, so I guess for me, at least, the way I would solve this would be to, first of all, simplify this bracket at the front to make it 2 plus 2x times the rest. Okay, and then this is just distribution, right? This is just multiply the 2 by everything, and then multiply the 2x by everything, and then add them together and simplify them. That's it. So we've got 2 times a half gives me 1, plus 2 times x over 16 is x over 8, and then we've got 3 over, what's it, 128 x squared. Okay, plus we've got 2x times a half is just x. 2x times x over 16 is going to be x squared over 8. And then finally, the last term will have an x and an x squared times together will make an x cubed. I'm not bothered about cubic terms, so I don't even need to do it, right? I just need to simplify what I've already got here. So there'll be higher order terms that I don't care about. This is then equal, so for 1, we just add the x's together. We've got 8 out of 8 x's plus 1 out of 8 is 9 out of 8 x's. And I can't do that in my head with the squares, so I'm just going to use a calculator for it. But it's essentially 1 out of 8 plus 3 out of 128.
At least I got the 1 right. I put 1 in front.
So this is 19 out of 128 x squared. So then A is 1, sorry, A is B. A is 1, B is 9 out of 8, and C is 19 out of 128. Okay. So I don't think C is particularly difficult. You can make your life a lot easier by recognizing which terms you don't need to take to distribute, which yeah, and just kind of like be very methodical with how you're working this out, and go step by step. Don't try and rush things. Like last year in GCSE, we could skip steps all the time, but with this kind of maths, you really can't. You have to be extremely careful, and especially with this. Right? Any questions on question 2?
No.
No, okay.
So,
Let's go for 3. All right. So similar kind of question, really. Expand this in ascending powers of x. So this time it's already in that form where it's 1 plus something to the power of something, up to and including the term in x cubed. So again, we're going to be using our binomial formula. So 1 plus nx plus n minus 1 over 2 factorial x squared plus so on. So let's do that. What have we got? 1 plus x over 2 to the minus 3. We've got 1 plus minus 3. X is x over 2 now, right? This is that. So our x over 2 gets substituted in for x plus minus 3 times minus 4 over 2 factorial x over 2 squared. And we need to go up to the cubic term, so I need one more. So we've got minus 3, minus 4, minus 5 over 3 factorial. And then we've got x over 2 cubed. Okay, and this looks horrible, but that's as complex as it's going to get. So now it's just about, can you simplify and be extremely careful as you do it. So we've got 1. Is it going to be positive or negative?
Negative.
Right.
Oh my God.
Numerator 3x, denominator 2. Positive. Numerator 12x squared. I'm going to try and skip a step here. Denominator 2 times 4 is 8. Right? Why is the denominator 2 times 4? Because you've got the 2 squared, which is 4. Okay. Next term, negative. Numerator 3 times 4 is 12, times 5 is 60. X cubed. We've got 3 factorial is 6 times 8. 5 8s are 40, 6 8s are 48. Done. Okay, now I'm not done because I need to simplify those fractions because I need them in their simplest terms. We've got 1 minus 3 over 2 is in its simplest terms. 12 over 8, well, they're both divisible by 4, so that's
3 over 2.
And then 60 over 48, I don't know, I'm going to use a calculator.
5 over 4.
Yeah, 5 over 4. Great.
Oh my gosh, finally I got it right. Thank God.
Okay, done. Express each coefficient as an exact fraction in its lowest terms. Find the range of values for which your expression is valid. So again, remember this is where mod of x, and in this case our x is x over 2 is less than 1. We don't have a negative, so we don't need to remove it. So just times both sides by 2, mod x is less than 2, which means that the range of values is between minus 2 and 2. And the reason that it's between minus 2 and 2 is if you imagine if x was 2, then it would cancel with the 2 in a denominator, which would make it 1, and therefore it wouldn't completely diverge, right? If it was slightly less than 2. If it was 2, it would diverge. So it can't be less than or equal to 2, it has to be less than 2. Okay. All right. Part B. Express 2 plus x to the minus 3 in that form. So now it's not in the nice form, so we need to make it in the nice form. Where a and b are rational numbers, so the fractions basically, whose values should be stated. Okay, so we've got 2 plus x to the minus 3. So let's work that out. B. Equals. So first of all, I need to factor out that 2. 1 plus x over 2 and it's all to the power minus 3. So now I need to use my rule of indices. This is 2 to the minus 3 times 1 plus x over 2 to the minus 3. 2 to the minus 3 is 1 over 2 cubed, which is 1 over 8. 1 plus x over 2 to the minus 3. So what was it? A was going to be the first one, and B is the coefficient of x. So A is 1/8, and B is 1/2. Okay, is that all right?
Yes.
Yep. Now we've got a function, and what you should notice is like we just found kind of like, if we look at this part here, this 2 plus x to the minus 3, that's 1/8 times what we found in part 1. So if we multiply that by 1/8, then we've got the denominator of this function. So then we have to multiply that by the numerator and distribute the 1 and the 4x over those terms. We need to do it all the way up to x squared terms. So we need to obtain a series expansion for this function up to the x squared terms. Okay, so this is going to be, let's say f of x is equal to 1 plus 4x times 2 plus x to the minus 3. Yeah. So 2 plus x to the minus 3, we need to work that out first, and I'll do it separately because it's 1/8 times what we got in part 1. So we need to distribute that. Because we're only going up to x squared, we don't need to distribute it over the x cubed term. We can ignore the x cubed term. So we just need the first 3 terms. So we've got 1 minus 3 over 2x. And then it's plus 3 over 2x squared. Minus, is it 5 over 4? Yeah, x cubed. Oh, I don't need it. Sorry. Okay. This is going to be 1/8 minus 3 over 16x plus 3 over 16x squared. Okay. So now f of x, I can say, is going to be 1 plus 4x multiplied by what's in my bracket. Okay, so I always distribute the 1 first. I just find it easier. So that's just going to be write out the sequence again, right? So we're going to have the first 3 terms be this. Then we need to multiply 4x by each term. So 4 over 8 is 1/2. So we've got x over 2. And then, so I'm doing this one. This one's going to be 4 3s are 12. It's minus 12x squared over 16. And finally, this one I don't need to do because that will give me a cubic term. Okay, so it's not too tricky. 1/8 doesn't get added to any other number. Then we've got minus 3 over 16 plus 8 over 16. 8 take 3 is 5, so this is 5 over 16x. And 3 over 16 minus 12 over 16 is minus 9 over 16x squared. Okay. So that's C done. D, hence obtain an estimate to 3 significant figures of that integral, of that function, right? Well, it's asking for an estimate. This is an estimate of the function, right? There will be some higher order terms, but these three terms will estimate that function. So part D is essentially just to integrate between 0 and 0.2 the estimate for the function, which you should now actually be able to do.
Well,
Okay.
Mr. David, if you get the first one wrong, then everything's wrong.
Yep.
So everything for me is wrong.
Yeah, so just make sure you know how to do those kinds of
A lot of
manipulations.
it is method marks, right? So even if you get some calculations wrong and your method is right for the next few steps.
Should be, yeah. But you'll probably lose all of the accuracy marks. So you'll get method
Yeah.
marks, but you'll lose a lot of accuracy marks.
Yeah.
Unless it says in the mark scheme that follow through marks are allowed. I've seen questions where they have been and where they haven't been. So I guess it depends. So this was a question 8 from a past paper. So it's one of the harder questions on the exam.
Yeah, it's
Yeah.
Mr. David,
Yep.
so for C, originality is like the thing divided by another number, but when we want to power it up, we need to time it. So this is what fx shows, right? For part C.
For part C.
Yeah.
So it's asking you to find the expansion for that function, right? And the denominator we already found. Well, we kind of found in part A, right? Because we've got we found the expansion of this in part A, which is very similar to 2 plus x all cubed. It's just a factor of 1/8. And then just multiply it by the numerator. So don't think about expanding this numerator. Just multiply it out like this. Yeah. So you'll have 1 times each of these, which was the first 3 terms. And then you'll have 4x times each of these, which is only the second 2 terms, because the very last term was x cubed. And it only asks me to do it up to and including x squared. So I didn't need to go up to x cubed.
Yeah, I can understand these steps. Yeah. Mm-hmm.
Okay. All right. Finally, just to finish off, do the integral. So we've got x over 8. Add 5x squared over 32. And what's 16, 32, 48 minus 9x cubed over 48. Evaluated from 0.0 to 0.2. So we don't need to plug in 0 because they'll all be 0. So you just plug in 0.2 for each of those terms. And what do you get?
So we plug in 0.2.
Yeah, so you'll have 0.2 over 8 plus 5 times 0.2 squared over 32. Subtract 0. So you should get 0.0298.
What? Why did you type so fast in the calculator, Mr. David?
I have an integral on my calculator. You can do integration.
Oh.
Oh yeah, that. Oh my.
Yeah.
Wait, let me see what I get.
Mr. David.
Yep.
I made a mistake on part C. Can I redo the whole thing and upload it again? I forgot the power. I expanded the equation differently, and then I forgot the minus powers. Can I redo it again?
No, I'm afraid not. So I just want to talk about the work that you guys are submitting now. It's gonna go towards my evidence for your level. So like, if you're dropping a few marks here and there, you're still going to get a good mark overall. I can't let you redo stuff too much. Like, you can make corrections to it by all means. Like, I'll mark it, give it back, you can correct it, and then that will go into my consideration of your level. But when you submit a piece of work, it needs to be of great quality, of good quality. And so I'm not going to give you tons and tons of work. I'm going to give you smaller pieces of work, but I want you to really make sure that they're done to the highest possible quality. And also make sure they're done on time, right? So check Google Classroom every day, but basically it's every Monday, Tuesday, and Friday you'll get assignments. Usually on Friday I'll give you until Saturday to do it, but I would just do them on those days and get them done. It's not really fair if I'm giving people extra time for assignments than other people, so please get them in on time. The other thing is, it's very difficult for me to mark them 3 days after when I've forgotten the mark scheme. So yeah, make sure you're doing your work on time, Monday, Tuesday, Friday, and make sure that it's to the highest possible quality. Because the marks that you get, I'm putting into like a spreadsheet, and then I can say, well, like, they got these marks on like sequences and series, they got these marks on reciprocal functions.
All going to be past paper questions?
Yeah, pretty much. So we're going to go on next week. We're going to go on to reciprocal functions. So I might give you a few more of these questions tomorrow, and then on Monday, Tuesday, we'll do some reciprocal functions. I'll go over it on Wednesday, Thursday, and then maybe we'll see where we are then. Is that all right?
All right. Mm-hmm.
Okay. I'll put the assignment up for tomorrow's work probably at some point today. And Trinity, Winston, I'll try and find you some different questions to do that are roughly the same amount of marks.
Yeah.
Okay. All right.
Okay.
Mr. David, what are you going to do with the recording of this class? Are you going to put it up somewhere? Or?
Thanks for reminding me. Yeah, I'll put it up on YouTube, so I can stop the recording now.